Okay, we've completed our titration now. We want to take a look at the calculations. First of all, let's look at the reaction itself. It's a neutralization reaction. We started with hydrochloric acid in the flask. It was an unknown concentration of hydrochloric acid. And we titrated that with sodium hydroxide, a strong base of a 0.10 molar concentration. And we ended up with salt, NaCl, and water, H2O. So we went from something that was very acidic and something that was very basic to something that was absolutely neutral. So at neutralization, at titration, at the end point, in other words, we have a pH of 7. Okay, so let's look at the calculations. First of all, the formula that we're going to be using is a fairly straightforward one. It's the molarity of the acid times the volume of the acid that was used is equal to the molarity of the base used to titrate times the volume of the base used to titrate. So the molarity of the acid then, the unknown molarity, times the volume. Notice we go to the 10th place here because I used the graduated cylinder to measure that volume. 20.0 milliliters of acid in the flask is equal to the molarity of the base, which was a 0.10 molar solution, that was a stock solution, times the titration, remember, required 32.2 milliliters of base for the complete neutralization to occur. I checked that at the very end of the titration. It was 32.2 milliliters. So when I do the calculation to calculate molarity of the acid, I simply say the molarity of the base times the volume of the base divided by 20 milliliters, or the volume of the acid, and I get this number here to two significant digits, 0.16 molar hydrochloric acid, and I now know the concentration of the hydrochloric acid. That's the titration. Okay, let's try titration then of a diprotic acid. Now, we didn't get a chance to do this in the laboratory, but let's give it a try. So let's take a look at this problem. It says 50.0 milliliters of a 0.5 molar potassium hydroxide solution is used to completely titrate 125 milliliters of sulfuric acid solution, that's H2SO4. What is the concentration of the H2SO4 solution? Okay, it's a simple titration like the one we did before, but there's a catch in this one, and that is that sulfuric acid is what we call a diprotic acid. What does that mean? So let's look a little bit more closely at how the neutralization is occurring in this titration. First of all, we had the potassium hydroxide. Nothing special about that. It dissociates just like sodium hydroxide. 1 mole of potassium hydroxide will dissociate into 1 mole of potassium ions and 1 mole of hydroxide ions. But 1 mole of sulfuric acid, or H2SO4, will completely dissociate into, because it's a strong acid, 2 moles of hydrogen ions, 2 moles of hydrogen ions, and 1 mole of sulfate ions. These are spectator ions. They don't enter into the pH calculations. But 2 moles of H plus is important. Why is that important? Well, let's do the calculation first. So we have the molarity of the acid times the volume of the acid is equal to the molarity of the base times the volume of the base. So we just proceed as normal. H2SO4 is the molarity of the acid. The volume of the acid is 125 milliliters, and that's equal to 0.5. That's the molarity of the base, 0.5. That's the molarity of the base that we used in this particular problem, times 50 milliliters. So when I do the calculation, when I do the division, 0.5 times 50 divided by 125 is a 0.2 molar sulfuric acid solution. But wait. First, we have to divide the final answer by 2 since sulfuric acid is a diprotic acid. 1 mole of sulfuric acid dissociates into 2 moles of hydrogen ions. So our final answer then would be 0.2 divided by 2, or a 0.1 molar sulfuric acid concentration. So this is a little bit of a twist on what we used, what we did in our actual titration. So you should know how to do titrations with monoprotic acids like the one we did in the laboratory, but you should also know how to do them with diprotic acids like sulfuric acid. That's all for now. I'll see you in the next video podcast. Thank you.